Chapter 8, Periodic Properties of the Elements. We talked about quantum mechanics and the dual nature of electrons and light. And in this chapter, we're going to talk about how quantum mechanics explains the behavior of matter. The first section, 8.1, I encourage you to read in your book. I'm not going to cover it in lecture or test you on it, but it kind of gives you a nice intro to why might we care about this. So I'll leave that a mystery and you can go read that for yourself. So we'll go straight to section 8.2. We talked about Dmitri Mendeleev a little bit when we introduced the periodic table. He ordered the elements by atomic mass and observed that there were repeating patterns of properties. And this gave rise to what's known as the periodic law. When elements are arranged in order of increasing atomic mass, certain properties recur periodically. And Mendeleev was able to use those patterns to predict properties of undiscovered elements. And there were occasionally places, like with tellurium and iodine, where if he put them in mass order, iodine should come before tellurium, but then the properties didn't line up. And so he felt that the properties were more important, and so he switched their masses. These are the sorts of predictions he was able to make. He predicted that an element below aluminum would be found. He called it eka aluminum, for below aluminum. It's now called gallium. These are his predictions. These are the actual properties. Look, he nailed the density, 5.9 grams per cubic centimeter. The atomic mass, pretty close. Melting point is low. The cool thing about gallium is it's a solid at room temperature, but it melts in your hand, right? Very cool. No, we can't play with it. Sorry. That would be fun, though. Eka silicon has been named germanium after Germany. And again, got really close on the density and the atomic mass, the formulas of oxides and chlorides. So the periodic law is a useful thing. It predicts what happens. That's what laws do, but it doesn't explain why. Why do these properties recur periodically? And that's what we're going to see with quantum mechanics. It's a theory, and it explains the why. So